Okay, hi guys. So today we'll be solving Leetcode problem, longest duplicate substring. So we're given a string S. Consider of duplicated substring, which means the contiguous substrings that occur 2 or more times. And we need to return any duplicate substring that has the longest possible length. And if the string S does not have a duplicate substring, and the answer is an empty string. So let's take a look at this example. We have a string banana, and then the longest duplicate substring is actually ANA. We can see ANA appear around here, and if we shift the pointer 2 steps ahead, we will reach here, which is another ANA. And that's the longest duplicate substring in this string, correct? And hence we return ANA. So how are we going to do this problem? How are we going to solve it? First, we need to recognize a pattern. Here, if I'm saying that there's a substring of length K, there's a duplicate substring of length K, then I can also say that there's also a duplicate substring of size K minus 1 and K minus 2, K minus 3, all the way to K minus I, where I is larger than 0 and smaller than K. Why? Because, for example, here, if I'm saying that we have a duplicate substring size 3, then I can also say that we have a duplicate substring size of 2. Why? You can take a substring of ANA, which means AN, right? And then that should be a duplicate substring of size 2, because AN will be encountered here and another time when we reach another substring, right? So if there's a substring of duplicate substring, right, of size K, there will be a duplicate substring of size I, where 0 I K, right? And this is a monotonic nature in which we can base on to actually solve this problem, right? We can use a binary search, and then we will define our search space consists of the length of the search space should be 1, right? And then the right of the search space should be equal to the length of this string, right? And then for each middle point, we will use a function to determine if there's a duplicate substring of this side equal to the midpoint. Okay, so you understand what I'm saying, right? So for example, in this input, we can set our search space from 1 and then 2 all the way to 6, and then we will have our midpoint somewhere in, I don't know, let's say 3 or 2, right? And then I say that 2 is a good answer. 2, there's actually a duplicate substring of size 2, right? Now I'm going to move our left pointer to 2, right? And then we have a new middle point. New middle point, for example, it could be 4, right? But 4 is not a good answer. So what are we going to do? We are going to shift our right pointer to mid -1. We need to exclude this guy from our search space, right? Because since 4 is not a good answer, then 5 cannot be a good answer, right? Based on this observation, 5, 6 cannot be a good answer, so there's no need to search for 5 or 6, right? So now we're going to shift our right pointer to 3, right? So now if we have a new middle point which is 3, 3 is a good answer, right? Oh, okay, 3 is good answer. I'm going to shift our left pointer to 3. Now we are at a position where our left and our right pointer meet each other, and here is our final result. So that's the easy part of the question, believe me or not. Okay, so how are we going to write a function to determine if there will be a duplicate substring of this side, window side, right? How are we going to do it? Okay, the inefficient way to do it would be to use a hash map, right? A hash map and a sliding window technique would be enough for this question, but it will be not that efficient. Why? I'm gonna show you my this is not a hard problem, but okay, so this is my first implementation where I use a hash map. Basically, then I'm going to have my right pointer that will kind of sliding through the string, and then I'm going to for each of the loop, I'm going to basically do a word slice, right, from 1 to the end of the current word, and then I'm going to add in the word that's going to be on the right. You can see here, but this is not efficient. I thought this was efficient, but up until I found out that string slice is actually open, or here we can say okay, where k is the length of the string. Con bà có rồi mà. K is the length of the string, right? So for each of the iteration, we need to do an operation that's going to be OK, where K is the strength of the window size, and that should not be that efficient, right? Can we do better? Yep, we can do better with a technique called Rabin-karp rolling hash, right? So rather than having to slicing our string and then concatenating the next character into our current string, we should be okay, right? We can actually calculate, we can actually encode each of the substring with a hash number, right? For example, here is a naive version of a Rabin-karp function. Here, let's say that we have a substring A, B, C, D, E, right? Okay, so now it's equal to 1, B, 2, 3, 4, 5, right? Let's say like this. And now we need to search for this pattern, and this pattern has a hash count of 1 plus 2 plus 3, which is equal to, let's say 6, right? Let's say 6. Here is actually BAC. Let's say that BAC. So now let's put this guy in here. I know. Okay, so now we will have a window size 3. Now we're going to calculate our hash value for this guy, which is 6 plus 2 plus 1, which is 9, right? So 9 is not equal to, for FBA, 9 is not equal to 6, so this guy cannot be the same string, right? You understand what I mean? If it's the same string, then it should at the minimum have the same hash value. So now it's not the same string. I'm going to shift our sliding window one step ahead. Okay, so now we have BAC. By doing that, we have to take the previous hash value minus this guy here, which is 6, and then plus this guy here, which is 3. Now we have what? We have 6. Oh, okay. We have BAC, which is 6, ABC, which is 6. Okay, so I'm going to conclude that. Okay, I found this guy, right? I'm finding that matching pattern, but not. Actually not. Why? Because BAC is not the same as ABC. And hence, this hash function, here I'm calling this hash function, is too weak. Right? This naive hash function is too weak to actually determine if a pattern is found or not. Okay, so here's the modern one. We can actually do, and since we only have consists of a lowercase Elix letter, let's say that I'm going to have a base of 26, and then we have a mod of here. Okay, so for this guy, what I'm going to do is I'm going to compute a hash value for it by using this function. I'm going to take the order of it, which is 1, right? A is 1, right? 1 multiplied by the base, and then I'm going to power it by actually the window size minus the index of that guy in the substring minus 1. Here it should be ABC is first in the substring, which has the index of 0. Our window size is 3, so I'm going to take 3 minus 1 minus 0, which is 2, right? Plus here, what is the value? BB is 2 base, and then this guy is 3 minus 1 minus 1 is 1, right? Plus C is 3 base 0, right? And that should be here plus here, right? And that will be evaluated to something I don't know, right? But that's actually how we are going to compute our hash value for each substring. I hope that you understand what I mean, right? But here's a thing about doing this in this technique. With this technique, is that we are going to get overflow, integer overflow, if we are not being careful. Why? Because this function, they all has power function, which can be really costly, right? Power function or modulus function is actually more costly than basic function like plus or minus, divide or multiply. If you're actually reading the book, you can search it on Google to they will basically tell you why is that costly. And another thing is that the hash value is going to be increased in a very fast space, and it's going to give you integer overflow. So here's what we are going to do to fix that. Is that we need to have a mod, and then for each of these functions we are going to mod them. If you understand what I mean, mod this guy, I'm going to mod this guy, and in the end when I'm having the final answer, I'm going to mod it again. Sounds crazy, right? But that's actually needed. Okay, so that's how we are going to compute our hash function. So what if I'm going to slide this guy? Okay, so in order to slice it, I'm going to take the previous hash value, going to multiply it by the base, right? If you understand what I mean, I'm going to take the order of the guy in the left pointer, right? Here, base, window size, because here we increase this by base, so now we need to minus this guy, pound it by window size, and then plus order as j plus window size minus 1, which actually mean what's on the right side, right? And then we're going to mod it. Okay, that's how we are going to compute our next hash value. And then since we also need to have a set of visited hash value, right? And when we compute a new hash value for a new substring, we going to search if it's already exist in the visited set or seen set. Then I'm going to say that okay, there's a duplicate substring of window this size, right? Okay, that's the explanation of okay, so one more thing, I'm going to actually be explaining things in more detail, because this technique has something that you can actually learn from. Okay, so you can say that even when we have a very complicated hash function like this, there could be still a possibilities where a different substring has the same hash value, right? It will be close to 0 but never 0, right? So if we are going to be naively say that if they have the same hash value and they are going to be the same, that's really risky, right? But in the scope of solving Leetcode problem, let's say that I'm going to be naively, right? I'm going to be very naive, and I'm going to basically say that it's going to be true. I'm going to believe 100% in my hash function, right? And then here, why can I choose this mod and base for our Rabin-karp rolling hash function? So basically it's a hash problem. So a rule of thumb is that you should choose a base based on the number of characters that's going to potentially exist in your string. Here it is 26, but I'm going to increase this to 31. Why? To reduce the strength of reduce strength of spurious hit. What is a spurious hit, or else known as a collision? A collision is when different substring has the same hash value, but they're actually not the same. That's a spurious hit, and that's going to be reduced if we actually increase our base. Okay, so why can we choose this mod? I know, I searched online. People say that I should use this, so I'm going to use it. That's an honest answer. Okay. So in real world problem, maybe we should be really careful, and once we compute a hash value and then we see it's already exist in the scene set, we should be careful and we should compare it with the previous substring that has the same value, right? And then if the two substring actually is the same, we can safely conclude that this window of size k has duplicate substring. But in the scope of this solving Leetcode, I'm going to be naive, right? Okay. Okay, so let's say I'm going to write our binary source functions first. So here we have start equal to -1, left right is equal to 1, and then len of s y. Okay, so mid is equal to, okay, let's say that position is equal to Rabin-karp mid. If post is not a -1, then I'm going to say, let's say that our Rabin-karp function is going to return -1 if there's not a duplicate in the substring of that window size, right? And then if it's return something that's not -1, then it's going to return the index of the index of the first character that appear in that duplicate substring, right? So if pass, which is the reason that our Rabin-karp function return is not -1, we're going to move our left pointer to mid, and then we are going to say start is equal to post, else r is equal to mid -1. You already know, if a substring size k is not going to be valid, then a substring size larger than k we cannot be the answer, right? And then we are going to say return empty if start is equal to -1, else s start l let me think about it a little bit. Start plus window size, which is l, right? L is the window size -1. Is that right? I know. Let's say we have a substring of size 3, right? Then we go to return this guy. Substring of size 3 starts plus stars plus 3, which is 4 minus 1. Yeah, okay, that's correct. So let's depth Rabin-karp window size scene set current hash current pound base pound. Okay, what we are going to do first is that we need to compute the hash value for the substring of the first sliding window, right? What we are going to say is that current hash is equal to current hash multiplied by base plus the order of for I in range window size. Current hash to be current hash multiplied by base plus order as I okay. I think I'm going to need to mod it, right? Okay, so base pound, I'm going to explain it to you guys later, because this is actually a little bit complicated. Why we need to actually check the base pound. Okay, it's equal to base pound base mod. Basically, for every like calculating step, we're going to end it with a module by mod to avoid integer overflow, right? And then so now we are going to slice it, right, in range 1 up until length of s minus window size. Let's say we have a window size of 3, and then now we have already successful calculate the hash value for the first window size. We already have 1, 2, and 3 left, right? That means 6 minus 3 plus 1. I don't know, plus 1. Yep. Yeah, so length size is 6, window size is 3. That's 3, but we are going to need to 1, 2. I'm a little bit bad at window slicing, to be honest. Okay. So here we successfully compute the hash value for the first sliding window. We need to add it to our scene set, right? Current hash. Let's add current hash. So we are now switching to a new current hash value, right? Would be the current hash. We need to multiply it by base, and then plus order s. We need to add in the guy at the end of the substring. So here we are at BAN, right? So now we are switching to ANA, which means we need to subtract this guy out and then add this guy in. That's basically what we are going to do for each step, right? So now we're going to add this guy in. That's order of sj plus window size one plus window size minus 1. Right. Here j is 1, 2, 3, 4, minus 1 is this, okay. And since this guy has a base of 26 and then the power of because it's at the end of the string, so the power will be 0, right? So 26 power 0 is 1, so we only need to plus this and then minus order sj minus 1, which this guy, right? Here we need to do base power here. So when that's why I'm going to need to pre-compute the base power first, right? Else we are going to need to recompute the base power for each of the iteration, and then the power function in Python or any other language is actually not efficient because it's a combination of multiplication. If you understand what I mean, if we power it by 2, that means one operation of multiplication, right? 3, that's 2 function of multiplication. If that's can grow to like 3 multiplied by 10 to power of 4, that can be really expensive for a large window size, right? So we need to pre-compute the base power first and then reuse it for each iteration, else our function can be really inefficient. Okay, so at the end of this we can actually mod it. If current hash in scene, I'm going to be enabling it. If it's in scene, I'm going to return the index, return j, else scene add current hash, and then once we exhaust the second for loop, we're going to return -1 since we do not return anything in the scope of that loop, right? Let's say what the hell? I know that is going to be incorrect. Why? Let's see. Current hash equal to current hash multiplied by base plus order of si, all of that going to be mod. Base power is actually the first base power is 1. Now I'm going to here. Okay, that's not wrong. That's not wrong, right? Then we need to add it to current hash to scene 1, then s minus window size plus 1, current hash is equal to current hash multiplied by base plus order s j plus window size minus 1 minus order s j minus 1 multiplied by base pound. I don't think that an or maybe I don't know. So then Rabin-karp side 3 0 1 2 3, that's correct. So why does it return an? Maybe something wrong with my binary search logic. If pulse is not -1, which means the window side of side mid is actually valid. Okay, maybe I'll okay, so here, because we already store our current best result in a variable called start, if you understand what I mean, we can actually shift our left pointer to mid plus 1 to search for the next best value, right? Else then we are going to say that why to do this? No, we can actually do this. Oh, can why? Mid. This is a little bit weird. It should work. I know it should work with let's see. This work, right? Don't need to explain about it, but I think the other way should also work, but let's just go with it for now. Okay, so passing all the test case, you can see. Now I'll go to here, submit. Okay, so it's really efficient, right? Compared to our hash map function, solution. It's actually fourfold, run fourfold faster in runtime, right? Okay, so that's it for today. So I hope that you guys understand the solution, and I'll see you guys in next video.